In this video, I'll be discussing heat transfer. So heat transfer is going to occur when you have two different systems of different temperatures that are put together. And eventually they'll reach a state of thermal equilibrium where they are both the same temperature. So there are two main equations that you're going to use for heat transfer. This main one is where Q, which is the symbol for heat, is equal to ms delta T, where m is mass in grams, S is the specific heat of your substance, and it has these units here, joules over grams times degrees Celsius. And delta T is the final temperature minus the initial temperature, and that's going to be in units of degrees Celsius. And we're going to use this Q equals ms delta T in combination with this equation over here, which is where you have the heat of system A is equal to the negative heat of system B. And this is the equation we're really going to use to calculate our thermal equilibrium temperature. So here's an example question down here. So if a 50-gram block of solid iron is heated to 600 degrees Celsius and placed into a beaker containing 500 milliliters of 25 degrees Celsius water, what will the temperature be of the system at thermal equilibrium? And you're given the specific heat of water and you're given the specific heat of iron. So first off, we need to establish how we're going to set up our equation. So what we're going to do is we're going to substitute the Q's in this equation here with this ms delta T system. So this is how we're going to set it up. So we're going to have ms delta T of system A, which is our iron, equal to the negative ms delta T of system B, which is the water. Now we need to actually plug in our values, and ultimately what we're going to do is solve for the final temperature. Tf is the temperature at thermal equilibrium, and that's ultimately what we want to end up solving for. So let's go ahead and plug in our values for this system. So here's our system set up. So over on this side we have our 50 grams of iron times the specific heat of iron, and I went ahead and broke up that delta T into T final minus T initial, because Tf is what we're trying to solve for, and you're going to use the temperature that you're given in the question as your T initial. So for the iron, that was 600 degrees Celsius, so you plug that in for Ti. And then over on this side we have our information for water, and one thing I would like to point out, always make sure you include that negative in front of your second system, because if you don't, that's going to screw up the entire question. So we have 500 grams of water, and I know in the question it said 500 milliliters, but for water, 1 milliliter is equal to 1 gram. So for water, whatever you have in milliliters, that's the same mass in grams. So we have 500 grams of water times the specific heat of water times T final minus our initial temperature of water, which was 25 degrees Celsius. So now what we want to go ahead and do is start distributing this stuff algebraically. So the first thing I would do is I would multiply 50 times this specific heat here, multiply negative 500 by this specific heat here, and then distribute that number to Tf and your number for T initial. And that will give us something to work with, because ultimately we're simplifying down to solve for Tf. So if you go ahead and do that and distribute that number to both of these terms, you should get 22.2 Tf minus 13,320 on this side, and you should get negative 2,092 Tf plus 52,300 on this side. And again, to do that, you just distribute, you multiply that 50 times the specific heat, and you distribute that number to Tf and to the initial temperature, and that's the same on both sides of this equation. So now go ahead and combine like terms. So I'm going to add this minus 13,320 to this side and combine it with this number, and I'm going to add this negative Tf value over here. So what you'll end up with is a Tf number on one side and a regular number on the other side, and that will allow us to solve for Tf. So you should get this, where we have 2,114.2 Tf equals 65,620. Now divide this 2,114.2 over to this side, and that will give us the value for Tf. And so once you do that, you should get your final temperature as 31 degrees Celsius. And this is the thermal temperature at equilibrium. So TF is ultimately usually what you solve for in these questions. There are other variables you can solve for. You can solve for specific heat. You can solve for mass. But ultimately, most of the questions involving heat transfer have you calculate the temperature at thermal equilibrium, which is TF.